Hello, everyone. I hope you all are doing well. Today, we are going to create a snakes and ladder game. Uh, we are going to discuss how a real software developer thinks, how he approaches problems, and how you should actually uh, think stuff before making it, right? This is going to be a low-level design video, an LLD video, where you are going to create a snakes and ladders game, right? So actually, this is a fresh project. This is a fresh IntelliJ IDEA project opened in Kotlin. We're going to create this snakes and ladders game in Kotlin, but most of the concepts are language agnostic. So you can like transfer your whatever you learn to any language, right? So yeah, let's dive right into it. Before trying to uh, just hop into coding, you should first try to write what you actually want to build. This is the most important step that new software like that like the this is the step that new people mostly skip, and this is actually the most important step, right? So we are trying to build a snakes yeah so we are trying to build a snakes and ladders game. And what you need to do is like you need to first think that what is actually that you need, right? So yeah, this is actually the most important step. And when you work in actual coding environments in the industry, in teams, we just name this as technical documentation, right? So let's start by writing what all do you need? What are the requirements of your software, right? So what do you need? Uh, the user should be able to play a game that contains players, right? This game should contain players. What else should it contain? A dice, right? A board. What else? Uh, yeah, this is pretty much about the game. What you can think of ahead is uh, on the board there should be your snakes and ladders. Snakes and ladders, right? This is something that will, when reached, either take you up or down the board, right? So landing on any one of these would either take you up or down the board, right? These are all like the features that you would be thinking to add, right? This is the most basic level of stuff that you need to think about before you start just making software. You need to know how the steps should go, right? Uh, so how the game would actually start, right? We should also discuss that how does the game start. So I am also like just creating this on the spot. So you can actually see that what goes into the mind, what goes on the mind, and what all are the processes, and how do we start thinking. And you should also try to do the same. And with time, this process just like comes naturally to you. How does the game start? The game should start in a way that the game should ask you how many players there are, right? It should first ask you how many players there are. Next, what? Uh, so uh, each player should get a chance where they can roll a die. right? Each player should get to roll a dice. Make sense? Yes. What else? Um, yeah. So if you talk about the dice next, um, the dice when rolled should give you a random number, right? The dice when rolled should give you a random integer. So can you guess what should be the limit? What should be the range of this random integer? It should be, it would firstly depend on how many dice do you have, right? If you have one dice, the number you land on should be between 1 and 36, 1 and 6, right? And if you start having two dice, it should be something between 1 and 12, right? So you should program it that way. Okay. So you have your dice there. What's next? Yeah, so we are having a game where there are players, dice, your board. We will start a game. The game will ask you how many players are there. Each player will get a chance where he will roll a dice, right? Uh, the dice when rolled will give you a random integer, right? And this would mark that the player has taken a chance, right? Now, um, after the die has actually given you a number, the player's position should be increased by that number. So you can like increment or decrement the position of the player on the board, right? This is something that you need. Yeah, and already we have already discussed about snakes and ladders, where landing on any one of these would take you to a random, like it could either take you up or down. Right, this is some basic stuff that we have discussed. Hmm. We should think more on this before we start coding actually. You should think about what can the player do? What can the player do? In such problems, you should always think about what are discrete uh, objects, logical objects that you can create, right? If I just talk about what are the objects that you can create, right? This is important thing. What are the objects that you can create? Can you think of any? You should be able to create a board. This is a specific board on which your game is being played. What should more you have? You should have a dice, right? This is a dice, and this is an actual piece in the game, right? Players, you have actual players there. There can be many players. So player is also an entity in your game. What else can you think? Snakes and ladders. Snakes and ladders. So your game basically is made up of these objects, right? Can't we say that? It's if you create all these things that can work together, then you can make a game that is working together, right? So, okay, you can say that there is a board that contains your snakes and ladders and your dice. Actually, there can be one more object. I would say there can be a game. And now your game should contain your board. Your board could should contain your dice and your snakes and ladders, right? I would like to design it that way, right? So I would say that actually your board should contain your snakes and ladders. And in the game, there should be your players. So something like that, right? If I start to, so your game contains of all these things, right? Now we can also define what all does these thing contains. What does your dice contain? What does your snake and ladders do? What do your players do? Right. We should think about this, and then we will come to your favorite part, that is coding. If we talk about dice, if we talk about dice, which is a very concrete thing. Um, it should have a function called roll die, right? It should have a function called roll dice, which should spit out an integer between 1 and the number of dice. So it will, this function will return an integer, an integer between 1 and number of dice multiplied by 6. Is that correct? Is that correct? So, no. Actually, it will always give us a number between number of dice and 6. Number of dice and 6. Right. So let's say that you have one dice. So the lower limit will be 1 and 1 into 6 is the upper limit. Let's say that you have two dice. Right. At this time, your dice, your pair of dice, the minimum limit can only be 2, and the maximum limit would be 2 into 6, that is 12, right? So this function works correctly. Do you understand this? So we have talked about your dice. What's next? Snakes and ladders. Uh, so if I talk about snakes first, so your snake is something that will take you to a lower position, right? Whatever position you are on, it will take you to a lower position. What are your ladders? It will take you to a higher position. So if you actually think, there won't be a function that you need to create. You just have to detect that you have reached a snake, and you just have to detect that you have reached a ladder, and you will have to change position based on that. Now, change position should be a function that should be handled by the player, not by the snakes and ladders. Your snakes and ladders are stuff that are just there. It's your it's your duty to detect them. So let's discuss about snakes and ladders in a while. Let's discuss the contract of your class player. Now, when I say the word contract, it means what all variables and functions does your class have. So your board is an entity, dice, snakes, ladders, players. These all are entities, and these are discrete nouns, you can say. These are discrete objects. So when I say objects here, I do not mean class is an objects. No, it is just a noun type of object, right? Right now we are only trying to think it out. We are not trying to say the DSA kind of objects and thing. No, this object is not the oops object. This is just the English object. Now player should have a function called take chance, right? This should have a function. Actually, this is how we are writing it right now. So this is a function called take chance. But before discussing the functions, it should have a data member, actually, right? It should have a data member called position. I should call it current position, right? So your player should have a current position, and this position should always point to the place where you are currently on the board, right? Your player should always remember where it is right now. Now, your player should have a take chance function that will take it to the next position based on what integer is returned by the dice, right? Is that correct? Do you understand this? So This function should roll the dice, and what should it do? This should roll the dice and increment the current position based on the number on the dice, right? Yeah. So we have thought about the player and the dice. So the only thing left is the snakes and ladders. We can also say that if the player lands on a snake or a ladder, it should also change its position based on that. Now, if you see what we are trying to do here, this is a very important concept. What we are trying to do here is we are trying to separate the concerns that are that come along with a particular class. What I mean by that is if we are having a class dice, the sole purpose of dice is to return an integer. Uh, it's to behave like a dice. It is there to give you a random number, right? The sole purpose of your player is to move the player up and based on the number that comes from the dice, right? See, I'm not trying to create everything just inside one class. I'm trying to separate out things there based on very real entities. At the same time, I am using OOPS, the object-oriented programming, in a way that it helps me build stuff in a very real life way. So I am trying to create each and every entity just the way it would behave in the real life, right? Things will get clear more when we start diving deep into it. Huh. Okay, let's see. Hmm. So I think we have most of our parts ready and thought out, right? We have most of our parts here ready and thought out. Uh, but all we don't have right now is our board. We kind of have to think about what kind of board mechanism we can have, which has several options, by the way, if you start thinking. So yeah, okay. Yeah, I will redo this. So let's say that this is your board. Okay. The board looks something like this. It has, I will create 5 of these. 1, 2, 3, 4, 5. Okay, let me create some more. And some of those like this, right? So how can you actually create a board? You can say that this is one position, this is 2, 3, 4, 5, this is 6. In the snakes and ladders game, it goes something like this: 6, 7, 8, 9, 10, 11, 12, something like this. And this is a 6 into 1, 2, 3, 4, 5, 6, 7. 7 6 are 42. So this should be 42. 1, 2, 3, 4, 5, 6, 7. Yeah. Right. Will it land there actually? Let me see. 1, 2, 3, 4, 5. Actually, 42 would be here, not there. Okay. Doesn't matter. Okay. So what would you think that you can either create a board like this. You can create a board using a 2D array. All you have to save is the position of the players, right? You just have to guess where the position of the players is. Also, there can be your snakes and ladders. Let's account for that as well. Let's just draw it so that we have a picture in mind. How do we change the color of this? Uh, I don't know. I don't know. Let's say that this one is your snake. Oh, we got something. Okay, we have something, yeah. Let's say that this is one of your snakes. So let's say that it this is the face and this is the tail of the snake. So if you land here, you will go here. And let me also make a ladder. I think this can be a ladder. So uh, this can act as a ladder, okay? Assume this is a ladder. So in case you landed at that position, this one, it will take you here, right? So we can have different entities. We can have two different classes for snakes and ladders, right? Or we can have just one class because snakes and ladders are just the same thing. All that they are doing is taking you from a position to a different position, right? So we can have a class like you can say jumper, right? You can create a jumper class. Jumper is a random word there, but what all that the class does is takes you from your current position to a different position, and the destination position can either be a larger number or a smaller number. You just have to change the position of your current player based on that, right? So we are going to get into the details of this a little later, uh, but yeah, let's discuss about the board first. So you can either create a 2D array and account for the positions, or the other way you can think about this problem, which might create things and your life a little bit easier, in my opinion, is that you can just create a single array. You can just create a single array, and you can say that this array goes from index 1 to 42. Actually, sorry, right. You can hold all your 42 positions in that one single array. So instead of thinking that your array is in 2D, you can think that just a second. You can also think that ये देखो, what I mean is this is your row. What if all these rows were stacked in front of each other? So this one would be here, let's suppose, and the third one would be here. So that would start looking like a single row, right? That would start looking like a single row. So you can think of it like that as well. So now if this is getting too confusing, you stay with me and let's start coding this, right? And then things would get much clearer. Okay, so yeah, let's get to your favorite part now, which is coding. We will start just this way. So, okay, I have a Kotlin package. Again, all the stuff is language agnostic. So just look at the concepts and you can translate these concepts everywhere. First and foremost, I would be creating my classes. I will need a board, right? As we discussed, I will need a board here. I will need another class called dice. I will need another class called player. And now we will start defining these, right? We will start defining these. I might as well get a class called game, right? I might as well get a class called game, which would be the most outer entity of our game, right? So let's say that your class game. So what I'm going to do next is give it some data members, right? In Kotlin, we give it like so val board, which is actually okay. I will start creating with the most basic thing, and then we will come up to here. Let's start with the dice. Dice is a very basic thing, right? So your class dice should contain a function function that will be roll dice, right? Is something that will give you a random integer between number of dice, and so your class dice should have one thing called actually let us make this private, and it should have one thing called number of dice, right? This would be of type integer. So yeah. So how will you define the roll dice function? It should give you a random integer between number of dice and 6 into number of dice, right? 6 multiplied by number of dice. Number of dice. So how do we get a random number? Okay, it would be returned simply random. Can I get a random function here? How do we get a random function in Kotlin? I do not know. I'm not sure. Uh, Number of dice dot dot 6 multiplied by number of dice dot random. I'm not sure. So let's look it up on the internet really quick. How to, so this is also something that you should learn. A software engineer doesn't always know the syntax, right? We also have to look up syntaxes. We do not remember that, and you do not need to remember syntax anytime. It's not at all important. All you should, uh, what you should learn actually is the process we are going through right now. You should learn this process. You should learn the process of how to make things and how to search for things on the Google to get things working. So how to get a random integer in a range in Kotlin. Okay, so the first result, yeah, looks promising. I think I would like to get on the Stack Overflow one. That looks better, but okay. Random dot next int 1 comma 100. So let's try that class. Uh, let's try that random dot next int. What does this function do? Like we can read it here. Gets the next random int from the random number generator. So does it have any parameters? Can it expect any parameters? Yes. So number of dice, comma 6 into number of dice. So yes, this can take two arguments. This is the range, right? So we are cool here. It will return us a number. Okay, cool. Let's talk about the player now. Your player again. This should have a private property. So in Kotlin, we can write data members right into that bracket. You also do this in C++ and Java, where you create members internally, and these are same things. Private val current position, right? This is something. Now, this is what we had discussed previously, right? We are able to do this so quickly just because we wrote it all in the starting itself. So we know what we have to do. We have a direction of about how to think through stuff. That's why this is the most important part, right? If you can figure this, then doing this is just like this can be done in any language. This just needs a little bit of logic and implementation, but thinking it through here is the most important part. So I will just do it the right way with the right syntax in Kotlin language, but you get the idea how we are going with this. So this is current position, and this is of type integer. Now your player should have something like take chance, right? It should have a function take chance. Now what will the take chance do? It will say ki, okay, I need a dice first, right? It will need a dice uh, of type dice. Now what will the player do? It will say that well, dice roll value, we can say something like that. Dice roll value. Okay. It is dice dot take dice dot roll dice, right? Dice roll. So you have a new integer value here. What you can do next is you can increment your current position based on the dice roll value. Is that correct? Yes, this is correct. What does it say? Okay, so we are having var because you are changing the current. This is val is a one time. If you define it, that val is like a constant value. Now you, since you cannot have a constant value, you should have a variable value. Okay, I'll try it. Keep it this way. So yeah, your player has taken a chance. Now there is one more aspect to it where there comes a snake or a ladder, but that is something that we will eventually discuss. Let's do the basic part first, right? So we can write something like a two that I'm commenting this that handles snakes and ladders as well. So if you actually want to see what all has happened until now, I will show you. But at the same time, we should have one more thing, right? We should have one more thing. Our player should not only consider that which position it is on. In order to uniquely define each of your players, you need a player ID. Let's say that ID is also int, right? We can say a player number. That would be much better. Player number of type integer. We can also optionally have a name. Let's say name of type string, and I will add a default parameter to it so that it's a default value. So you don't have to necessarily put a value to the name, right? So yes. Now let's just see what all we have done, right? Just a very quick one. Let's say, let me define a player. Let me create a player here. And this is a new player. In Kotlin, we do it like this. In Java, you would do something like player is equal to new player, something like that. Something similar in C++ as well. Okay. So you have created a player. Let us give it current position 1, right? Yeah. So in the beginning, everyone should have the position of 1, player number 1, let's just say. And what I want to see is that if this actually works. So does take chance work? Oh, now it would require a dice, right? So you would also have to create a dice. Let me create a new dice. Well, dice is equal to dice. And it will again ask how many dice do you want? Let's say your game has 2 dice. So I can expect that the dice can give us a random integer between 1 and 12. So, your take chance should give a dice, right? Let us create one more function get that says get current position, and it will simply output your current position. Println current position. Okay, you can say that. So yeah. So we can also do something like hmm, player dot get current position. We can also do player dot get current position before we even take the chance, right? So yeah, so let's try to run this and see. So all we are trying to, I am trying to show is that what we have done until now. So before taking the chance, it was 1. After taking the chance, it's 3. So the random number that must have come there would have been 2. Let's do it. Let's run it once again. A different number should. So this time it's 1 and 5. So every time a random number may come. Right. Okay. So things are working. We can see things are working. Okay. Now let's go to the next step. Um, we have made our player. We have made our dice. Right. Let's make a board. Let's make a board. So we should define something like max position. This would be type integer, right? Do you understand what this is? And let's say that our max position is 100. Now I will say that this is a private val max position of 100. In Kotlin, we can make something like data classes. Not a big deal. Okay, I'll remove this. This is something that is concerning you. Okay. Okay, so you have a board. What all can your board contain? Let's think about that. Your board should contain dice, snakes, ladders, and players. Okay. Hmm. So these three things are part of your board, right? Players are not the part of your board. Just think logically, think it through logically, and you will get it. You can, if you don't like what I'm saying, you can also create your players inside the board and then see what happens. Also, one thing that you should remember is there is no only one right answer in low level design. You have to modify things. Each question can be solved in multiple ways. It's just that how the developer is thinking at the moment. Also, the thinking should also be in line with what kind of functionality are you actually going to achieve. And also, you should create a system that is most optimized in nature. But okay, let's say that your board has a max position. Hmm? Your board should also have, your board should know how many dice are there. Okay, let me think this through. Hmm. Your board has a max position. Okay, let's think about the dice. Your game should know how many dice are there. Your game should know how many dice are there. So your dice becomes a part of the game. So now I'm thinking that way, right? So let's do that first. I think that I should have a game, right? I should have a class called game. Now my game should have something like board. My game should have a board, right? This is something I myself I'm speaking, so I'm trusting my intuition and I'm going forward with this. My game should have a board and my game should have a dice, dice, right? Private val dice, sorry. And my game should have my players. My game should have my players. Well, I should have players. Now, players is something which is a array list of players. It's a list of players, right? So I will create an array list there. Array list of player. Are we getting this? This makes sense, right? Now my game should have something like start game, right? It should have something like start game. Um, Also, it should have something like hmm, next chance. So whoever is the next player should take their chance. Hmm. Okay. This makes sense until here. My board. My board should have a maximum position. What else should it have? Yeah, this is all I can think of in my board class right now. I should have a dice. I should have my player. Okay, your board should have your snakes and ladders. That's an important thing, right? So think of your snakes and ladders as things that will transport you to a new position based on your current position. So what I'm trying to do is let's get on our whiteboard once again. So yeah, this is how you should think actually. Hmm, can I get a different color? Okay, I have a different color. So please think of this. Let's say that you took your chance and you somehow came here, right? If now there is no snake or ladder here, so the next player would get their chance, right? But let's say that there is a snake or ladder there. Let's say that this position is 6 plus 5, that is 11, right? This position is 11. Now let's say that here is a ladder and it takes you to a position 30, right? It takes you to a position 30. So let's say that you have a ladder that takes you from 11 to 30. So what you have to check in the moment is if your player lands on position 11, we should immediately come to know that now we have to jump to position 30. So we should be able to detect now in term. So you should be able to detect that at position 11, there is a ladder which takes you to 30. Let's say that there is a position 12, and for example, there is a snake at it that takes you to position 6. So at 12, there is a snake that takes you to a position 6. So in the moment, you should immediately be able to judge that you do have something there that will transport to a different position. Okay. Are we getting this? Can we think of a data structure that can quickly help us do this job? Does is there anything that clicks your mind at in an instant that which data structure will help you get this in the most efficient way possible? Do you think that a hash map would do this? Isn't this a key value pair? Isn't this a key value pair? Like this, your 11 is a key. Why is it the key? Why should your 11 be the key and why should your 30 be the value? Why can we not have your 30 as the key and 11 as your value? Because your key is something that gives that where the searching happens in over time, and that is the fastest we can go. So you're basically, if you think snakes and ladders, first of all, are the same things. They are just like transporters. They will transport you from one position, start, to the destination position, end. You just have to know that there is a snake or a ladder sitting on that position. How will you know that? You can store it in an array, no problem. Make an array, right? Make an array that somehow tells you that, okay, 11 takes you to 30. Now search in the array, do something. I don't know. You can make a custom class key value pair. Now search through the array that do you have a position. Uh, let's say that you have a class called transporter. Transporter. Now it has two values. It has a start, it has a destination. Now your 11 can be your start, your 30 can be your destination for a ladder type of transporter. You can keep this that in an array or a list. Like keep all your transporters in a array. And you can just search here and okay, just search through the array that if you have a starting position of 11 in any of the transporters, this is your array of transporters, and search in your transporter array if you have a starter of start position 11. You will get that in ON time. So why will I waste my time? Why will I create a game that is taking so much time? Okay, I think I've explained enough on this, but your hash map would be something that will take you the fastest there. We don't need more discussion on this, but if you are still having problems, please put them in the comment section, and I myself or someone else will explain you why this is happening. But I think there should be a very clear explanation of why a hash map should be there. That should house, that should enclose your start and destination positions. It will quickly tell you that on 11 there is a transporter. I don't care if it's a snake or a ladder. I just have to know that it's there, right? Think from the perspective of someone who is making the game, right? Okay, let's get into the coding of this. So I will create a new class called transporter now. I will create a new class called transporter now, which we had forgotten, or we had deferred this part. Transporter. Okay, this is very fancy. Okay, so my transporter has something called a start position, which is of type int, and it should have a destination position of type int. I will make these two vals, not private ones. This time we are not creating private. Okay, we have our classes here. Again, please don't uh, get into the comment section. The Kotlin ninjas, please don't come there and say, why didn't you make a data class? This is just for demonstration purposes, and I want things to be as language agnostic and easy for other people as well. So, okay, you have your board. Okay, you have your board, and I'm going to create a hash map of transporters, transporters, transporters. Okay, what have I done? Mm, Never mind. We should not have made that class called transporter. It's not needed. Now this is the hash map of start and end destination. It's of type int and int. Okay. So what's the problem? Hash map of, okay, in Kotlin we declare it this way, hash map of something comma something. Okay, I will have to declare a type int comma int. Okay, now our hash map is ready. We did not need this transporter class. This is not needed. We are just creating a hash map. Okay, this is easy stuff. Okay, this is easy stuff. Now let's create random hash maps. Okay, please come with me on this. So okay, let's say that you actually have a ladder. Let me create a ladder first. So a ladder would be something like from 11 it takes to you to 30. Okay, what's the problem now? Uh, okay, I think we declare it this way. Yeah, in Kotlin we declare it this way. So this is a ladder. Okay, this is a ladder. It takes you to from 11 to 30. Okay, let me create some more ladders. Okay, so let me create one from okay, 27. 27 to where? 39. Okay, let me create one more. Okay, there must be a ladder at 79 and it takes you to 90. Please, this is a hash map. Okay, you might, in your language it might be created with a different syntax, but it is a very simple thing. Map of something to something. We have three ladders. Let me make four snakes now. Okay, I will take you from 99 to to 4. That is so exciting. Okay, from 65 to 43, and from I maybe 12, 21 to 1. Okay, looks very nice. So these all are our transporters. Okay, cool, cool. I do not need this transporter class. I'll just delete this. Hmm. Okay. Inside your board, you have your snakes and ladders. Your transporters are your snakes and ladders. Now we are towards the very completion of our thing, of our game. Now, okay. Your player can take a chance, right? Okay, we can start from the starting ones. You have a game, and we will define the start game and next chance functions in a while, but inside your game there is a board, right? Inside your game there is a board. Inside your game there are dice. Inside your game there are players, right? So you have a board, and inside your board there are snakes and ladders. Your transporters are snakes and ladders. Next, you have dice. Your dice has a simple function that gives you a random number between the limits we have already discussed. You have a player. Your player can take their chance where they roll a die and their current position changes. And you have a function that returns your current position. Okay. Now, if you think it is your player's duty that in case you land on a, if you land on a this, okay, actually, okay, it's not your player's duty, right? It's not your player's duty. It's the game's duty. So in the game's next chance function, we can maybe do that. Okay, we will think this out. No problem. We can also do something like change position to. We can make a function like change position to. And now what I'm doing is uh, I'm saying something like destination position of type integer. What it's going to do is, in case somehow a ladder comes or a snake comes, we will just tell that, okay, now your new destination position is going to be this position. So in that case, your current position would be your destination position. Okay, simple thing. So you can also just remove this and say change position to, um, it would be current position plus dice roll position, right? Yeah, makes sense. Okay, 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 all good, all good. If you think about the game now, if you think about the game now, in order to start a game, you should create a board. You should create a dice. Inside the board, you will have a dice as well, right? You don't have a dice. No problem. In order to start a game, in order to create a game, you will need a board, you will need a dice, and you will have to take some players. And hmm, at any point of time, you should know that which player played last, and based on that, you should take us to the next player. So you have to create that kind of logic. So yeah, val current player is equal to mm, we have a list of players, right? So we have a list of players and I'm setting it to 0. Obviously in starting, you are on the 0th player. Um, you can also say something like val current player index is equal to 0. We can just keep a track of the index, and the max index would be the number of players, right? Are we getting this? We are just trying to create a loop where each next player gets their chance. So how will you make this next chance function? Maybe pause this video, and if you are following along, write the logic for the next chance. I'll be doing it now. Um, hmm. So what you can do is, Yeah, you can say that the player, your current player, you can ask your current player to take chance. Okay, we have missed one thing where we do the transporter. Okay, my bad, my bad. Let's think about that after making this game. What's your next chance? Current player dot take chance. It will need a dice. You have to provide the dice to it. Right? I have provided the dice to it. The start game function is something where you will define this dice. You will define this board. Okay. We will do that in a while. You asked your current player to take their chance. Now it's duty of the player uh to take their piece to the appropriate position. Okay. Don't worry about that now. What the game will do next is it will say that current player index is equal to current player index plus one. Right. It's telling us to do this. At the same time, this should be a variable now. And this should also be a variable. Current player will keep on changing. Hmm. We missed one thing. Your current player. Okay, we will change the current player now. Now the current player would be current player index. Yeah. No, it's players of current player index. Simple. Right. Right. Yes. What you should keep in mind before doing this is if current player index is already number of players dot size. So um, if it's not if it's not the number of size, you can do that. But if it's already equal to the size, what will you do? The next player would be player number zero, right? So the current player index would become zero suddenly, and the current player would be players of current player index, right? We are repeating these lines. We can pull these out, but okay, I'll keep it this way for, okay, let's pull these out. So what this logic is doing now, it's just updating the index of your current player, right? So if it's equal to the number of players, if it's equal to the list, then it says that now the index is on zeroth. Otherwise, let's say that you have five players. So first zeroth player will play, then the first one, because players is current index is not equal to size yet. It keeps on incrementing by one. So 0, 1, 2, 3, 4. 4 is, that means five players have played. When it increments once again, so it comes to 5 and then it becomes 0. So now all your players will get a chance. Okay, let's define our start game function. So let's just say that, okay, we do not need this function right now. Now, can you guess until when is this going to repeat? Keep on taking chances. It's going to keep on doing this until a particular player reaches the maximum value of your board. Let's do this. First, I'll try to run this. So, see, we are going to create a game. I created a game. Now, what does the game need? Your game needs players. Okay, let's see. It needs a board. So let's create a board first. Well, board. It's a board, right? What does your board need? Your board needs a maximum position. Let's not keep this private. Your board needs a maximum position. So let's say that the max position is 100. I will create a constant. I will create a constant const val max position. Okay, so you have a board that goes until 100. What's max? I don't know, it's creating a problem. I'll just simply put 100 in here. Okay, sorry. So sorry. Okay, so sorry. Const val max position. Okay, you have a board that goes until maximum position. Also, your game would need something else as well. This would be a dice. I will create a dice now. So you have a val dice. It's a dice equal to dice. How many dice will your game have? Let's say two. It's going to be a number of dice. Now, why am I creating constants like these? No reason. Readability. There's some optimization that happens as well, but we do not need to discuss in that in this particular video. Um, because that would be too much information for you people. Now there's a list of players. Let me create a list of players of a game. List of players. I'm going to hard code a list of players, but always what you can do is you can create a list dynamically as well. You will create a loop there, which would say something like, hey, player number one, what's your name? Something like that. Okay, so current position is always one for any player. It's the starting position. Player number for first player, I'll put one, and for the name, I'll put, okay, I'll put just once. Now, this current position should be one, player number should be two now. I'll just omit this value, not needed, not compulsory, as we already put a default value there. So 3, 4, 5, right? So you have 5 players. Each of your players have a number. So this is a list. Okay. You have to pass these variables to your game now. You have to pass your board. You have to pass your dice. You have to pass your players. List of players. Are you following until now? So I created an array list. Okay. I'll put array list of. This is also cool. Okay, so we were going to discuss until when is your game going to run, right? So let me actually create a function start game, which I thought was not needed. And I would say that while we can store something like var max position of player. This is like the position of the winning player that has the maximum value. So what I'm going to do is current player, after your player takes the chance, I'm going to say that max position of player is equal to current player. Since your current player has taken the chance, dot change position to, sorry, we need to get the position. Okay. Okay. What does that get? Okay. Get current position is not returning a position right now. We will have to return current position. Now you may ask, okay, you won't ask. Hmm. So can you guess the condition? What would be the condition when the next player won't take their chance? I will say next chance. So until when should this happen? Yes, until your max this max current is equal to or greater than what board dot max position. I can say that this can be maximum possible position. Right. On the board, there can be a maximum possible position, right? Which is 100. Okay. So yeah, we have created our game, right? We have created our game. All we haven't done right now is do something with our jumpers, but let's see how this works, right? Let's see if our game actually ends or not, because our game will actually end. There is no such thing that will get your player from your current position to a lower position. That's never going to happen. Right. Okay. So yes, this is your game. And now what I'm going to do is game dot start game. What this is going to do is it's going to get our game into a loop that will keep on playing. Also, for you to visually see the progress of your game, I'm going to, in the next chance, I'm going to create a function key log chance info. Okay. Well, what I'm going to do is it's just I'm just going to log out what's happening. Okay. This is a very simple thing where I will do something like current player dot. I'm going to say println now current player dot uh, get current position. I'm also going to do something like current player dot just going to give this a val, no big thing. Player number. It's going to be something like uh, player number this player number this went went is now on position this. Okay, so player number this is on now on position that. Okay, it's just going to log that out. And hmm when we are actually going to exit the loop, we are going to log out the winner. Okay. We will log out the winner. And who's going to be the winner? The player that took the last chance. So game is won by player and current player dot player number. Okay, so this will tell you who won the game. Let's see if this works or not. So, okay, I hope there's no errors. Game is won by player one. How come? Why didn't we get any logs? Um, when, oh, uh, so okay, I think we wrote something wrong. While the maximum position of a player is less than the board, until then only it should run. That became a logical problem. Okay. Index 5 out of 5. Okay, let's see. Uh, this is it's saying that the looping is having a problem. Okay, so next chance function, what it's doing, it's saying current player index is not equal to, okay, we can say, huh. So if it is greater than or equal to, okay, as soon as it becomes equal, as soon as it becomes equal, we should, if it is less, we are going to increment it. If anything else, we are going to put it to 0. Now it should work. Oh, just put, okay, now should it work? Okay, we got it. I'm going to uh, put the log correctly again so that we can read it properly. Okay, so let's see. Each time player one, next player two. So 1, 2, 3, 4, and 5 are taking chances at the right times. So player 1 goes to position 3, 2 goes to 9, 3 goes to 12. Is that possible? Yes, 12 minus 3 is 9. So jump of a 9. So yeah, it all looks good. 4 is on 15. 5 is 4 was previously on 11. Okay. 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 So numbers are incrementing only. So no problem there. And finally, someone reaches on 100. So game is won by player 3. So it incremented once. So okay, no problem. Uh, well, logging is being done here. Okay. The game was won by player 2, but it incremented somehow. So okay. We have made a game successfully. Now the only thing left is your jumper, your transporter. Let's do that also, which is very easy and quick to do. Okay. I hope you understood until here. Now the jumper part is also very easy, right? It's very easy. So you have your player, right? Your player gets, hmm, your player gets a dice as well. Okay. Where is the take chance? Your take chance. So your player gets a dice, right? Your player gets a dice to take their chance. Now let's say that the player also gets their board, and there they can see um if we are currently on a snake or ladder or something. Right now I'm going to make a function called check snakes and ladders. Okay, I'm going to say that check snakes and ladders. This is going to be a new function. I'll create it here itself. Check snakes and ladders. This is a function that cannot be called from outside the class. So I am going to make this function private. Please don't ask me why. I'm going to make this function also private because I do not want if that this function is called from outside the class without the permissions of this class, because it should be only the contract of this particular class that this function can be called, because if someone is calling it from outside, they could tamper with the value, right? This is something that you will understand with time. But okay, for example, your get current position, this should be something that can be accessed by outside. But at the same time, your current position field member is always private, right? Because you cannot just randomly change the current position of the player from outside. So these are important things. Okay, we are about to end with this tutorial. So what you did was you took a chance, you rolled the dice, you you went to the new position. Now what you have to do is, based on the new position on the dice, you will check if you are on a position where there are snakes or ladders, right? So simply check snakes and ladders. You will say, okay, pass your board to this, pass your board to this as a parameter. Okay, pass your board here. Okay, now val uh, does trans. So what let's create a logic that if there is a if there exists a value, if there exists a key pointing to the current position on your board, then transport us to a new position. Else simply leave us where we are. Did you understand that? Let's do this. It's very easy. I'll say val new position is equal to if if your board if your board dot transporters dot contains key. To get you a little less confused, I'll write this once again. Let's do something like board dot transporters dot contains key. Contains key. Let's say, does it contain your current position? Does it contain your current position? Is it a Boolean value that coming out? Okay, it will give you a Boolean. Well, does transporter exist? Okay, does transporter exist? If it does, if, if transporter exists, then what you will do is you will simply change your current position to the position pointed by the board dot transporters dot yeah, your key is simply your current position. We definitely know that this position exists, so I'll use some other function so that you do not get so confused. Let me check if there is one. Dot now. Okay, I'll just use get or default. What it will do is return me either your current position or, so this is a very important thing. And what it's doing is, please understand, it changes your current position to either two of the things. So if your hash map has a value corresponding to your current position, Let's say you are at position 11. Let's say that you are at position 11 and your transporter transports you to position 30. Right, so it will return 30 and your current position will change to 30. If it does not, so it will get a default value, and we have defined our default value to our current position only. So there is no snake or ladder at position 11. So it will return the position, the current position only. Are you getting this? Does this make sense? Yes, this makes sense. At this point, I'm also going to print uh, transporter. Never mind. Okay, never mind. Okay. Yes, so the now your game is actually complete where you have your snakes and ladders and all of the stuff. No value passed for board. Okay, we forgot to add one value here. So in your take chance function, you also needed your board. Now you are passing your board as well. Okay, so now I can run this. Now actually your game is fully ready. Player 3 can be on 101, right? If he's currently on 99 and suddenly a value of 2 comes. So that's how. Player is one, game is won by fourth, so we are not going to do that. Player game should always be won by the person who got their chance last, but this will actually fail when person 0 will take the chance and win, because that would give you -1. um but okay, it's okay. What's the next thing we can do? We can just maybe once check that if I'm just going to demonstrate that there can be snakes and ladder bites. If board dot transporters dot contains key current position, I'm just going to show you how snakes and ladders are working. Println transporter found at current position. So I will add one more thing like transporting from. Okay, that's something that I'm going to do. And so these are places where transporter have been found. Just trying to show you. At 99, I put a transporter that brings you to 4, right? So this is about that. Game is won by player 5. Not actually player 5, player 4 won the game. But it increments it before. We can solve that, but I think you would be able to do that yourself well. You can debug that much. And yes, this is how you think through. And this has been a long video. So yeah, see you in the next one.